Smart city infrastructure, the future of transportation and urban planning. The future of transportation and urban planning is being shaped by smart city infrastructure. This video explores how cutting-edge technology and innovative design are being used to create more efficient, sustainable, and livable urban environments. Animated logo intro with upbeat music. Welcome to Civil Engineering Edge, your ultimate source for insight, innovation, and inspiration in civil engineering. If you're passionate about shaping the future of our cities, don't forget to like, share, and subscribe. Imagine a city where traffic jams are a thing of the past, where public transport runs like clockwork, where data from sensors, vehicles, and buildings work together to create cleaner, safer, and more efficient environments. Welcome to the future. Welcome to Smart City Infrastructure. In today's video, we're diving deep into how smart city infrastructure is revolutionizing transportation and urban planning. Let's explore how technology and innovation are building a more connected, sustainable, and livable urban future. 1. Intelligent transportation systems. Smart cities begin with smarter transport. Intelligent transportation systems are already being deployed in cities across the globe. These systems use real-time data from traffic cameras, GPS, and IoT sensors to manage traffic flow, reduce congestion, and improve safety. Adaptive traffic signals can adjust timing based on real-time conditions. Smart parking systems guide drivers to available spots using apps or digital signage, saving time and reducing emissions. 2. Integrated and multimodal transport. The future of transportation is all about integration. Smart cities are combining buses, metros, trams, bicycles, and ride-sharing services into one seamless experience. Apps like Mass Mobility as a service allow users to plan, book, and pay for their journeys across multiple modes of transport in a single app. This shift promotes public transport over private vehicle use, easing traffic congestion and reducing pollution. 3. Urban planning with data-driven design. Urban planners now have powerful tools powered by AI and big data. By analyzing traffic patterns, footfall, environmental impact, and energy usage, planners can make smarter decisions. Digital twins, virtual models of real-world cities, help simulate and optimize infrastructure before it's even built. This reduces costs, increases efficiency, and allows cities to plan proactively instead of reactively. 4. Sustainability and green mobility. Electric buses, bike-sharing programs, pedestrian-friendly zones, and green corridors are central to smart city planning. These solutions help lower carbon emissions, reduce noise pollution, and improve public health. Smart energy grids and eco-friendly building designs work hand-in-hand with smart transportation to make cities more sustainable. 5. The role of AI, IoT, and 5G. AI-powered traffic prediction, 5G-enabled vehicle communication, and IoT sensors in roads and buildings allow cities to monitor and manage resources in real time. This network of intelligence is what turns an ordinary city into a smart one. Conclusion: smart city infrastructure isn't just the future, it's already here. As civil engineers, urban planners, and technology developers come together, we are witnessing the transformation of cities into dynamic, data-driven ecosystems. Stay tuned to Civil Engineering Edge for more deep dives into the future of engineering and design. The smart city revolution is just beginning. Are you ready to be part of it? If you found this video informative, don't forget to like, subscribe, and click the bell icon to stay updated with the latest in civil engineering and infrastructure. This is Civil Engineering Edge, shaping the future one blueprint at a time. The challenges of urbanization. Welcome to Civil Engineering Edge, your go-to channel for deep insights into modern infrastructure, smart design, and the future of engineering. Today, we're exploring one of the biggest questions facing our cities: how smart infrastructure can overcome the challenges of urbanization. Section 1. The urban boom. Urbanization is accelerating at an unprecedented rate. By 2050, nearly 70% of the world's population is expected to live in urban areas. But with this growth comes enormous pressure on our infrastructure, environment, and quality of life. We're seeing rising traffic congestion, housing shortages, water scarcity, and energy demands like never before. Cities are expanding faster than they can adapt, creating urban chaos instead of urban development. So, how do we fix this? Section 2. The role of smart city infrastructure. This is where smart city infrastructure steps in. Smart cities are built on data, connectivity, and sustainability. Using technologies like AI, IoT, 5G, and cloud computing, urban areas can become more responsive, efficient, and livable. But here's the key: smart solutions must directly address the challenges of urbanization. Traffic overload. Smart traffic lights, real-time data, and autonomous vehicles. Overpopulation. High density, mixed-use zoning, and modular housing. Resource shortages. Smart grids, rainwater harvesting, and waste-to-energy systems. It's not just about futuristic tech, it's about smart planning, design, and management. Section 3. Key challenges cities face. Today, let's break down the 5 key urbanization challenges smart infrastructure must overcome. 1. Traffic congestion, wasting time, energy, and productivity. 2. Environmental pollution, air and water quality degrading public health. 3. Housing inequality, informal settlements growing without proper planning. 4. Aging infrastructure. Many cities still rely on outdated roads, pipes, and utilities. 5. Urban sprawl, spreading too fast, consuming farmland and green space. Solving these isn't easy. It takes vision, innovation, and cross-disciplinary teamwork. Section 4. Case studies and solutions. Cities like Singapore, Barcelona, and Amsterdam are already showing the way forward. Singapore uses sensors to manage traffic, lighting, and waste systems efficiently. Barcelona's super blocks reduce car traffic and give space back to pedestrians. Amsterdam promotes green transport and circular construction. Each of these examples proves that smart infrastructure works best when it puts people first. Tech is the tool, but human-centered design is the real goal. Conclusion: urbanization is a challenge, but also a massive opportunity. Smart city infrastructure is not just about building better cities, it's about building better futures. At Civil Engineering Edge, we believe in cities that are resilient, inclusive, and ready for what's next. Like what you saw. Hit like, smash subscribe, and ring that bell icon for more smart engineering content every week. Visuals, smart city animation with subscribe button, video suggestions, and Civil Engineering Edge branding. Growing populations and limited resources create pressure on cities. Animation transition or visual of an urban city skyline. Welcome back to Civil Engineering Edge, where we uncover how modern cities are evolving with technology. In this segment, we tackle a core challenge of the 21st century: how growing populations and limited resources are creating pressure on our cities. Section 1. The urban strain. Urbanization is booming. Every minute, nearly 150 people move into cities. That's over 200,000 people per day around the world. But while populations are growing, resources are not. Cities are now facing severe pressure on housing, water, energy, transportation, waste systems, and public services. Infrastructure that was built decades ago is now bursting at the seams. Let's take a closer look. Section 2. Limited resources meet rising demand. Water shortages are becoming more frequent. Energy demands are skyrocketing. Public transit is overburdened, and land for development is shrinking. These challenges are especially severe in megacities urban centers with more than 10 million people. Cities like Mumbai, Lagos, and Sao Paulo are struggling to meet the basic needs of their populations. Traditional infrastructure just can't keep up. We need smarter, faster, and more flexible systems. Section 3. The Smart Infrastructure Solution. Smart city infrastructure is designed to do more with less. It relies on real-time data, predictive analytics, and AI-driven control systems to manage limited resources efficiently. Smart water grids detect leaks instantly and optimize distribution. Energy management systems balance power loads and integrate renewable sources. Traffic and transit analytics help reroute flows and reduce peak time strain. And all of this happens behind the scenes, invisible, but incredibly powerful. Section 4. Affordable and scalable solutions. The key to solving urban pressure isn't just in technology, it's in smart design and planning. Modular housing units can be built quickly and scaled as populations grow. Mixed-use developments reduce the need for long commutes, cutting down on traffic and pollution. Vertical farming and smart waste processing reduce the load on traditional supply chains. All these solutions reduce the burden on land, resources, and infrastructure while enhancing the quality of life. Section 5. Community-centric smart cities. The smartest cities are not just the most connected, but the most equitable. They ensure that growth doesn't leave people behind. By involving citizens in planning and using data to understand their needs, cities become not just efficient, but truly livable. The population is growing. Resources are limited, but with innovation, collaboration, and smart infrastructure, we can turn urban pressure into urban progress. Subscribe to Civil Engineering Edge and join us as we explore the technologies shaping tomorrow's world today. Smarter cities start with smarter engineers like you. Smart city visuals, video suggestions. Subscribe. Traffic congestion, pollution, and lack of affordable housing become critical issues. Scene transition from the previous segment, fading into aerial footage of a traffic-clogged city and smoky skyline. As populations rise and resources stretch thin, cities face three major challenges that threaten sustainability and quality of life: traffic congestion, pollution, and lack of affordable housing. Let's take a closer look at these critical issues. Section 1. The Gridlock Crisis. Traffic congestion is no longer just an inconvenience, it's a major economic and environmental problem. According to global studies, people in urban areas spend over 100 hours a year stuck in traffic. That's productivity lost and stress levels rising. More vehicles on the road means more fuel burned, more emissions, and more pressure on outdated transport infrastructure. The answer isn't always building more roads. It's about building smarter mobility systems. Section 2. Urban air under attack. With congestion comes a more dangerous problem: pollution. Urban air quality is deteriorating. Many cities exceed safe limits for particulate matter and carbon emissions. The result? Increased respiratory illness, reduced life expectancy, and declining livability. But smart cities are fighting back. Electric public transport reduces vehicle emissions. Green zones and low-emission areas limit polluting vehicles in dense districts. Air quality sensors provide real-time data to adjust traffic and alert citizens. These systems turn data into cleaner, healthier environments. Section 3. The Housing Affordability Crisis. As more people migrate to cities, housing demand surges, but affordable housing doesn't always keep up. This leads to overcrowding, informal settlements, and rising rental prices that push lower-income families to the margins. Smart cities are now looking at innovative housing solutions. 3D printed homes that are faster and cheaper to build. Micro-apartments with shared community spaces. modular and prefabricated housing that can be scaled quickly. Alongside this, smart zoning policies promote mixed-use development, creating walkable neighborhoods where people can live, work, and thrive without long commutes. Section 4. Designing for equity and livability. Smart infrastructure isn't just about technology, it's about equity and livability. Solving traffic and housing issues means designing cities that prioritize people, not just vehicles or buildings. Wider sidewalks and bike lanes reduce car dependence. Transit-oriented development clusters homes around public transport hubs. Mixed-income housing ensures diversity and inclusion in every neighborhood. By focusing on human-centered urban design, we create cities that are efficient, inclusive, and resilient. Outrow transition, traffic, pollution, and housing may be today's biggest urban challenges, but with smart planning and innovative engineering, they're also our greatest opportunities. Stay with Civil Engineering Edge as we explore how technology is transforming not just our cities, but our way of life. We'll dive into how data, AI, and community feedback shape truly intelligent cities. Don't miss it. Rolling City Planning with subscribe button and next video previews. Smart clean streets and futuristic traditional approaches to urban planning are no longer sufficient. Footage of congested urban streets fading into architectural blueprints of old city plans. In the face of rapid population growth, environmental strain, and rising demand for smarter solutions, one thing is clear: traditional approaches to urban planning are no longer sufficient. Section 1. The old model no longer works. For decades, urban development followed a linear, compartmentalized approach. Residential zones here, commercial there, roads in between. It was functional, but rigid. This model led to urban sprawl, increased car dependency, and inefficient land use. The result? Longer commutes, more traffic, fragmented communities, and a widening gap between planning and real human needs. But today's cities require something much more dynamic, integrated, and responsive. Section 2. Enter smart urbanism. Smart urban planning turns this old model on its head. Instead of static master plans, we now use real-time data, AI-powered simulations, and digital twins to test, predict, and adapt city layouts. These tools allow planners to analyze pedestrian and traffic flows instantly, forecast the impact of a new park, bridge, or metro line before it's built, use community feedback gathered through apps and platforms to co-design neighborhoods. This is urban planning for the 21st century: flexible, inclusive, and driven by evidence. Section 3. Breaking silos with interdisciplinary design. Old planning relied heavily on isolated departments: transport separate from housing, housing separate from utilities. Today's smart cities break these silos through interdisciplinary collaboration. Civil engineers, data scientists, architects, and sociologists now work together. Smart grid designers collaborate with urban planners for optimal energy usage. Mobility planners design multimodal transport systems integrating metros, e-bikes, autonomous shuttles, and pedestrian networks. This holistic approach creates cities that work as systems, not separate parts. Section 4. Agile planning for a changing world. We live in a fast-changing world. Climate change, pandemics, and digital disruption have shown us that cities must be able to adapt quickly. Smart planning introduces agility. Zoning laws are becoming more flexible, allowing for temporary uses and fast shifts. Building codes adapt to new construction technologies like 3D printing and modular design. Public spaces are designed to serve multiple purposes: markets today, emergency shelters tomorrow. We're moving from fixed plans to fluid frameworks. Outrow and CTA. Traditional planning served its time, but it can't meet the complexity of modern urban life. Smart cities need smart planners, and that means embracing data, innovation, and a people-first approach. At Civil Engineering Edge, we dive into the future of cities where infrastructure meets intelligence. Up next, we explore the tools that power smart planning, from sensors and satellites to AI and urban digital twins. Like, subscribe, and ring the bell to keep learning how tomorrow's cities are being built today. Modern city animations with digital overlays, data points, and engineers at work. Subscribe. Introducing Smart City Infrastructure. This section flows naturally after the discussion on how traditional urban planning is no longer sufficient. It now shifts into the heart of your topic: what smart city infrastructure actually is, how it works, and why it matters. Visual. A transition from traditional cityscapes to futuristic smart cities with vibrant digital overlays and clean, green streets. Narrator engaging tone. We've seen the challenges. We've seen the limitations of old methods. Now, let's dive into the solution that's transforming cities across the globe: smart city infrastructure. Section 1. What is smart city infrastructure? Smart city infrastructure refers to the integration of advanced technologies, data systems, and intelligent design into the physical structures that support urban life. This includes roads and transport networks, water and waste systems, energy grids and buildings, public safety and environmental monitoring. But what makes them smart? It's not just hardware, it's how technology, sensors, and data are used to optimize performance and improve citizens' lives. Section 2. The core technologies behind smart cities. Smart city infrastructure is powered by a blend of cutting-edge digital technologies, including Internet of Things (IoT), sensors embedded in roads, buildings, and utilities collect real-time data. Artificial intelligence (AI) analyzes data to make predictions and automate decisions, like adjusting traffic signals to ease congestion. Cloud computing and big data stores and processes huge volumes of city data for planners and managers. 5G connectivity enables fast, reliable communication between devices, vehicles, and systems. Together, these technologies form the digital nervous system of a smart city. Section 3. Smart infrastructure in action. So, how does this look in real life? Smart traffic lights reduce idle time and pollution by adjusting to real-time vehicle flow. Digital public transport maps provide live updates and rerouting. Smart grids balance electricity loads and integrate renewable energy. Waste bins send alerts when they're full, optimizing pickup routes. Everything is connected, measured, and managed to maximize efficiency, safety, and sustainability. Section 4. Infrastructure meets innovation. Smart city infrastructure isn't just high-tech, it's highly strategic. Urban planners and engineers are embedding intelligence into every layer of city design. Buildings are being constructed with sensors and smart materials. Roads are being designed to support autonomous vehicles. Bridges and tunnels are embedded with self-monitoring systems that alert for stress or damage. This transforms infrastructure from static objects to dynamic systems that learn and evolve. Smart city infrastructure is not a concept for the future, it's happening right now, reshaping how we live, move, and connect. On Civil Engineering Edge, we continue exploring how technology is redefining civil engineering and urban planning, one smart solution at a time. Coming up next, we'll explore how smart mobility is solving the toughest transportation problems in urban areas. Don't forget to like, subscribe, and hit the bell icon to stay at the edge of engineering innovation. Outrow visuals, animation of smart city layers, energy grid, traffic, housing, services, working together with dynamic infographics and data points. Smart cities leverage technology to address urban challenges. This segment follows naturally after the introduction to smart city infrastructure and now highlights how that infrastructure directly solves real-world urban problems. Visual. animated icons of traffic, pollution, housing, and energy transforming into tech-enabled solutions like smart signals, electric buses, green buildings. Smart cities do more than adopt new technology, they use it strategically to solve some of the biggest challenges facing modern urban life. Section 1. Turning data into solutions. 011 to 120. At the core of every smart city is one powerful asset: data. Sensors placed across the city collect real-time information on traffic, pollution, water usage, energy demand, and even foot traffic. But raw data means nothing without intelligent analysis. Cities use AI and machine learning to transform this data into action. Rerouting traffic in real time, detecting water leaks before they cause damage, predicting energy demand, and adjusting supply accordingly. This turns passive infrastructure into adaptive systems that respond as conditions change. Section 2. Smarter mobility for smoother cities. One of the most visible benefits of smart technology is in urban transportation. Smart mobility systems reduce congestion and improve public transport by using adaptive traffic signals to clear intersections, offering real-time transit tracking to passengers, encouraging the use of e-scooters, shared bikes, and electric buses, supporting autonomous vehicles with connected roads and navigation data. All of these reduce carbon emissions, travel time, and urban stress. Section 3. Tackling pollution and climate change. Narrator: pollution and climate threats demand immediate innovation, and smart cities deliver. Smart tech enables air quality monitoring block by block, dynamic low-emission zones that restrict polluting vehicles, smart energy grids that prioritize solar, wind, and other renewables, green building systems that auto-regulate lighting, heating, and ventilate cleaner air, more sustainable power, and cities that meet environmental goals. Section 4. Affordable housing and inclusive design. Technology isn't just for efficiency, it's also for equity. Smart cities use data and design tools too. Identify underutilized land for affordable housing development. Streamline the permit and construction process through digital platforms. Monitor community needs and adjust infrastructure investments accordingly. Design neighborhoods that are safe, walkable, and well-connected for everyone. This ensures urban growth is inclusive, not exclusive. By harnessing technology in thoughtful, targeted ways, smart cities don't just survive, they thrive. They meet today's challenges head-on and prepare for the ones still to come. Stay with Civil Engineering Edge as we continue our journey into smart solutions that are reshaping the cities of tomorrow. Next, we'll take a closer look at smart mobility and how it's redefining transportation from the ground up. Like, share, and subscribe to keep up with the future of engineering and urban planning only on Civil Engineering Edge. Outrow visuals, futuristic roads with driverless vehicles, solar panels, green buildings, and people interacting with smart kiosks. Sensors, data analytics, and AI are used to optimize city operations. This segment builds on the previous discussion about how technology solves urban challenges, and now it dives deeper into the how through the integration of sensors, data, and AI that makes city systems smarter and more efficient. Transition in, visual, zoom into a bustling city from above with animated icons of sensors, data clouds, and AI circuits flowing between buildings and infrastructure. To truly understand how smart cities function, we need to go behind the scenes into the systems that collect data, analyze it, and turn it into real-time decisions. It all starts with sensors, data analytics, and artificial intelligence. Section 1. Sensors. The eyes and ears of the city. Sensors are everywhere in a smart city. They're embedded in roads, traffic lights, buildings, utility lines, public transport, and even trash bins. They continuously monitor traffic flow and congestion. air quality and temperature, water pressure, leaks and usage, energy consumption in buildings, noise levels, and pedestrian activity. These sensors act as the nervous system of the city, collecting millions of data points every second. Section 2. Data analytics, making sense of the information. But collecting data is only step 1. The real power lies in analyzing it. Cities use advanced data analytics tools to identify patterns in traffic to predict and prevent congestion, optimize trash collection routes to save fuel and time, spot unusual spikes in water or energy use that may signal leaks or system failures, understand how people move through a city and which areas need more services. This transforms raw numbers into actionable insights that improve decision-making. Section 3. Artificial intelligence, smart, self-learning systems. Artificial intelligence takes it a step further. AI algorithms don't just analyze data, they learn from it. They can detect patterns that humans might miss and adjust systems autonomously. Traffic signals adapt in real time to reduce delays. Smart thermostats regulate building temperatures based on usage patterns. AI in public safety systems can detect unusual behavior and alert authorities. Predictive maintenance tools can forecast equipment failures before they happen. AI makes the city adaptive, proactive, and continuously improving. Section 4. Real-time optimization in everyday life. Let's look at a real-world example. A smart traffic system in a major city detects an accident. Sensors pick up the slowdown. The data is sent instantly to a control center, where AI reroutes vehicles and extends green lights on alternate routes. Commuters using public transit apps get real-time updates and alternative options all within seconds. This is real-time optimization, turning complexity into smooth flow. And the same logic applies to electricity grids, emergency response, parking, and even air quality control. Sensors monitor, analytics understand, and AI takes action. That's how smart cities stay ahead of the curve, constantly improving the quality of life for their citizens. At Civil Engineering Edge, we're uncovering the tech-driven future of urban design and transportation. In the next chapter, we'll explore how smart mobility solutions like autonomous vehicles and integrated public transport are transforming how we move through our cities. Like, subscribe, and turn on notifications so you don't miss what's next in the smart city revolution, only on Civil Engineering Edge. Motorcycle, a day in the life montage of a smart city commuters navigating with apps, AI traffic management in action, and clean, connected neighborhoods. This creates more efficient, sustainable, and livable urban environments. This segment connects everything discussed so far, emphasizing the outcomes of smart city technologies: efficiency, sustainability, and livability, the ultimate goals of urban planning in the modern era. Visual, from networks of data and AI, the screen transitions to green parks, public transport in motion, smart buildings, and happy city dwellers. When smart city systems work together, sensors, AI, data, and infrastructure, the result is transformational. Cities become not just smarter, but more efficient, more sustainable, and far more livable for everyone. Section 1. Greater efficiency in city systems. Efficiency is the foundation of a smart city. Energy is not wasted because smart grids supply power exactly where and when it's needed. Traffic delays are minimized because roads adjust in real time. Water systems detect leaks automatically, saving millions of liters. Government services go digital, reducing paperwork and wait times. These improvements reduce costs for the city and make daily life faster, smoother, and more predictable for residents. Section 2. Sustainability at the core. Smart cities are also leading the way in sustainability. Smart buildings use less energy through intelligent HVAC and lighting systems. Public transport becomes cleaner with electric buses and optimized routes. Air and noise pollution are monitored and actively managed. Urban green spaces are designed with climate and biodiversity in mind. With climate change being a growing threat, these cities set an example of how urban development can align with environmental responsibility. Section 3. Improving quality of life. Most importantly, smart infrastructure makes cities more livable. People spend less time in traffic and more time with family. Access to affordable housing, healthcare, and education improves through data-driven planning. Neighborhoods become walkable, safer, and more connected. Public services become personalized, faster, and more transparent. In a smart city, technology serves people, not the other way around. Section 4. The big picture. When a city becomes smart, it's not just about adopting new technology, it's about creating an ecosystem where everything works in harmony. The outcome is a place that runs smoother, grows cleaner, and feels better to live in. At Civil Engineering Edge, we believe the cities of the future aren't built with concrete alone, they're built with intelligence, empathy, and innovation. In our final segment, we'll explore real-world example cities already implementing these smart solutions and what we can learn from them. Like this video if you're inspired by the possibilities of smart infrastructure, and don't forget to subscribe for more stories from the front lines of civil engineering. Visuals: citizens biking on smart paths, drones inspecting infrastructure, kids playing in digitally managed green parks. The future in action. Smart transportation solutions. Visual: animated transition showing traditional city roads transforming into smart mobility systems, autonomous buses, intelligent traffic signals, ride-sharing, bike lanes. In the heart of every smart city lies a revolution in how people move. Welcome to the era of smart transportation solutions designed to make urban mobility cleaner, faster, and more connected than ever before. Section 1. Intelligent traffic management. Let's start with one of the biggest urban headaches: traffic congestion. Smart transportation systems use real-time traffic data, cameras, and AI to adjust signal timings dynamically, identify traffic jams, and reroute drivers via apps, coordinate emergency vehicles through green wave corridors, reduce wait times at busy intersections. The result: smoother flows, fewer delays, and reduced emissions. Section 2. Connected and sustainable public transit. Public transportation is also evolving, becoming smarter and greener. Cities are adopting electric and hybrid buses with zero emissions, real-time tracking apps that update riders with accurate arrival times, smart bus stops with solar panels, digital screens, and Wi-Fi, integrated payment systems like smart cards and mobile apps for seamless travel. This not only reduces pollution, but makes public transit more reliable and attractive for daily commuters. Section 3. Autonomous and shared mobility. The future also belongs to autonomous vehicles and shared mobility. Self-driving cars and buses are being tested in urban corridors. Ride-sharing platforms use AI to match routes and reduce redundant trips. Cities are creating mobility hubs where bikes, scooters, and shuttles connect seamlessly. Apps help residents choose the fastest, cleanest mode of transport based on live data. This reduces the number of private vehicles on the road, easing pressure on infrastructure. Section 4. Last mile connectivity and active mobility. Smart transportation isn't just about vehicles, it's about people. Bicycle lanes and pedestrian zones are being expanded and connected. Shared e-scooters and bikes fill the last mile gap between public transport and home. Smart navigation apps help users plan multimodal trips: bike to metro, metro to bus, bus to office. The goal: mobility that's flexible, inclusive, and healthy. Smart transportation is not a luxury, it's a necessity in tomorrow's cities. From AI-driven signals to electric buses and shared micromobility, these innovations are helping cities breathe easier, move faster, and live better. Coming up next on Civil Engineering Edge, we'll explore real-world examples global cities already implementing smart transport systems and how they're transforming daily life. If you're excited by the future of urban mobility, don't forget to like, comment, and subscribe to stay on the cutting edge only on Civil Engineering Edge. Visual: a vibrant cityscape at night filled with glowing roads, electric vehicles, data-driven navigation maps, and eco-friendly transit. Connected vehicles and autonomous driving systems reduce traffic congestion and accidents. Visual: slow-motion shot of a modern city street where autonomous electric vehicles drive smoothly, exchanging real-time data with traffic systems. As cities continue to evolve, transportation is undergoing a revolution led by connected vehicles and autonomous driving systems that promise a safer, more efficient urban experience. Section 1. What are connected vehicles? Connected vehicles are cars, buses, and even delivery trucks that communicate wirelessly with each other and with infrastructure like traffic lights, road sensors, and cloud-based systems. This communication, known as Vehicle-to-Everything V2Xe, allows vehicles to share real-time speed, location, and direction, receive alerts about accidents or roadblocks ahead, sync with traffic signals to improve flow, adapt speed or rear out in response to congestion. The result: less stop-and-go traffic and fewer unexpected delays. Section 2. Smarter decisions through AI. These vehicles are also equipped with artificial intelligence that enables them to make split-second driving decisions. AI processes input from cameras and radar for obstacle detection, LiDAR for accurate 3D mapping of surroundings, GPS and navigation for optimized routing. This level of automation allows the vehicle to respond faster than a human, reducing the risk of accidents caused by distraction, fatigue, or poor judgment. Section 3. The rise of autonomous driving. Autonomous vehicles (AVS) take things a step further, driving with little to no human input. Cities around the world are testing autonomous shuttles, taxis, and buses in controlled environments. These systems operate with predictable driving patterns, obey speed limits and safety regulations at all times, reduce human error, which causes over 90% of traffic accidents. Autonomous fleets can also be centrally managed, optimizing routes across the entire city for maximum efficiency. Section 4. Less congestion, fewer accidents. Together, connected and autonomous vehicles are already showing major benefits. Traffic congestion is reduced as vehicles avoid bottlenecks and maintain steady speeds. Commute times shrink as the system redirects flows dynamically. Accident rates drop significantly due to better coordination and faster reaction times. Fuel consumption decreases, leading to lower emissions and cleaner air. This isn't just a win for transportation, it's a win for urban livability and sustainability. As connected and autonomous vehicle technology continues to evolve, we move closer to a future where roads are safer, commutes are shorter, and cities are smarter in every sense of the word. Next on Civil Engineering Edge, we'll look at how integrated transport networks bring together every mode: bikes, buses, trains, and more into a seamless urban experience. Don't forget to subscribe, share your thoughts in the comments, and stay tuned as we explore more about the future of smart cities, a futuristic city intersection where autonomous cars, buses, and bikes all move in harmony, guided by invisible data networks. Real-time traffic monitoring and dynamic routing optimize travel times. Visual: a busy city highway with live traffic heat maps overlaid, transitioning two cars being rerouted via GPS in real time. Imagine a city where traffic lights respond to the flow of cars, navigation systems instantly reroute around congestion, and your daily commute becomes faster every day. Thanks to real-time traffic monitoring and dynamic routing, this future is already here. Section 1. The power of real-time monitoring. Smart cities are built on a foundation of real-time data collection, using technologies like GPS tracking in vehicles, IoT-enabled traffic cameras and road sensors, mobile data from ride-sharing and navigation apps. Cities gather constant information on vehicle speeds, traffic density, and road incidents. This live feed is sent to centralized traffic control systems, where it's analyzed and used to make decisions within seconds. Section 2. Dynamic routing in action. With that real-time data, smart cities enable dynamic routing, a system where vehicles are automatically guided along the most efficient paths. Here's how it works. Navigation apps like Google Maps or Waze analyze traffic conditions and adjust routes on the fly. Public transit buses change their paths slightly to avoid delays. Emergency vehicles are rerouted for the fastest response times. Freight and delivery systems optimize their schedules, saving time and fuel. The result: reduced congestion, shorter travel times, and fewer delays. Section 3. Adaptive traffic signals and smart intersections. It's not just about routes, even traffic signals adapt. Smart intersections adjust light cycles based on real-time vehicle counts, pedestrian presence, time of day, and historical patterns. This means less idle time at red lights and a more fluid traffic experience. And during events, accidents, or construction, the system adapts automatically, no human input required. Section 4. Data-driven efficiency. By analyzing traffic trends over time, cities can also improve long-term planning. Pinpoint chronic bottlenecks. Identify areas needing infrastructure upgrades. Design better bus routes or bike lanes based on real usage data. All of this is powered by the same real-time traffic intelligence that improves daily movement. With real-time monitoring and dynamic routing, travel in smart cities becomes smarter, smoother, and more predictable. Whether you're driving to work, riding a bus, or biking across town, data makes it better. In the next chapter on Civil Engineering Edge, we'll explore how cities are integrating multiple transportation modes, creating seamless, multimodal travel experiences for their citizens. Like, comment, and subscribe if you're excited about the technology shaping the cities of tomorrow. A live city dashboard displaying traffic flow in green, navigation rerouting updates, and a commuter smiling as they arrive early. Smart parking systems help drivers find available parking spaces quickly. Visual, frustrated driver circling a busy urban block, fading into a calm driver being guided to an open parking spot via a mobile app. Wasting time looking for parking. You're not alone. In fact, studies show drivers can spend up to 20 minutes circling for a spot. But in a smart city, even parking is getting smarter. Section 1. The parking problem. Finding parking in a busy city isn't just annoying, it causes increased traffic congestion, wasted fuel, and higher emissions, driver stress, and lost productivity. That's where smart parking systems step in, turning a frustrating chore into a fast and easy process. Section 2. How smart parking works. Smart parking systems use sensors embedded in parking spots to detect availability, cameras and AI algorithms to track usage, mobile apps and in-car navigation to guide drivers directly to open spaces. These systems are connected to a centralized cloud platform that updates availability in real time so drivers always know where to go before they even arrive. Section 3. Smart apps and digital payments. With smart parking, it's not just about finding a spot, it's about convenience. Use mobile apps to reserve a space ahead of time. Get notifications when your time is about to expire. Pay digitally, no more digging for coins or paper tickets. Integrate with other services like ride-sharing or public transit apps. This saves time, cuts emissions, and even reduces city enforcement costs. Section 4. Citywide impact. Smart parking also helps city planners identify high-demand zones, Adjust pricing dynamically based on demand. Improve urban traffic flow by reducing unnecessary driving. The result: less congestion, cleaner air, and a better experience for everyone, drivers and pedestrians alike. From smart meters to real-time maps, smart parking is more than convenience, it's a critical part of a smarter, greener city. Coming up next on Civil Engineering Edge, we'll explore how urban planning is being transformed by data-driven design and citizen-centric development models. Like, comment, and subscribe for more deep dives into the smart technologies shaping our urban future. Visual: a clean city block where cars smoothly glide into marked smart parking zones, guided by app notifications and glowing LED indicators. Sustainable urban design. Visual: a time lapse of a city skyline transitioning from a concrete jungle into a lush, green, smart city filled with bike lanes, rooftop gardens, and solar panels. In the age of rapid urban growth, building smarter also means building sustainably. Smart city infrastructure goes beyond technology. It embraces urban design that respects nature, reduces waste, and enhances quality of life. Section 1. What is sustainable urban design? Sustainable urban design is about planning cities that are environmentally friendly, energy efficient, resource conscious, and most importantly, livable for generations to come. It combines ecological awareness with innovative engineering, blending smart infrastructure with green spaces, efficient buildings, and inclusive layouts. Section 2. Greener infrastructure. Smart cities incorporate green infrastructure elements like urban forests and rooftop gardens that cool the environment and clean the air, permeable pavements that reduce stormwater runoff, green belts and open spaces to preserve biodiversity, vertical farming, and community gardens that promote local food production. All of this creates a healthier, cooler, and more sustainable city environment. Section 3. Eco-friendly buildings and energy efficiency. Modern urban design also includes smart buildings that regulate their own energy use, solar panels and renewable energy systems integrated into infrastructure, efficient water recycling and waste management systems, LEED certified construction practices that minimize carbon footprints. These buildings are not just homes or offices, they're active participants in the city's sustainability goals. Section 4. Human-centered, walkable cities. Sustainable design also means planning for people, not just cars. That's why smart cities prioritize walkable neighborhoods, bike-friendly infrastructure, public transport access within minutes of every home, mixed-use development, reducing the need for long commutes. This encourages healthier lifestyles, builds stronger communities, and helps cut emissions. Sustainable urban design isn't a luxury, it's a necessity. And in a smart city, it becomes the foundation for everything, from transportation to housing, from parks to power grids. On the next episode of Civil Engineering Edge, we'll dive deeper into how smart cities are empowering communities through inclusive and participatory planning. Don't forget to like, share, and subscribe for more insights into the future of our cities smarter, greener, and built for all. Visual: drone shot pulling back from a smart, green neighborhood to reveal a vast eco-conscious city buzzing with life and innovation. Smart cities promote sustainable development by integrating renewable energy sources. Visual: solar panels glistening on rooftops, wind turbines turning on the horizon, and EVs charging under solar-powered stations. To build cities of the future, we must rethink how we power them. Smart cities don't just use energy, they generate it sustainably. By integrating renewable energy sources, they promote true long-term development without sacrificing the planet. Section 1. The role of renewable energy. Renewable energy is the lifeblood of sustainable cities. Whether it's solar panels on rooftops, wind turbines on the outskirts, hydropower, geothermal, or biogas systems, Smart cities harness these clean energy sources to reduce dependence on fossil fuels and lower carbon emissions. This shift supports climate goals, reduces pollution, and ensures a resilient energy future. Section 2. Smart integration of solar and wind. In many cities, solar power is now seamlessly embedded into residential rooftops, commercial buildings, parking lots, and even bus stops. Meanwhile, urban wind turbines supplement the grid, especially in windy coastal or open areas. Smart grids monitor energy production in real time, automatically balancing supply and demand, maximizing efficiency and minimizing waste. Section 3. Smart grids and storage. A key part of this system is the smart grid, an intelligent energy network that detects where energy is needed most, stores excess energy in batteries or vehicle-to-grid systems, prioritizes renewable sources when available, helps residents track and reduce their energy usage. It's like having a digital brain managing the entire city's power ecosystem. Section 4. Electrification of mobility. Smart cities also promote electric vehicles EVs powered by renewables. Public EV charging stations are solar-powered, strategically located across neighborhoods, integrated with public transit hubs. Even buses, trains, and delivery fleets are going electric, creating a zero-emission transportation network. By integrating renewable energy into every layer of the city homes, businesses, transportation, and infrastructure, smart cities ensure that progress doesn't come at the cost of the environment. Up next on Civil Engineering Edge, we'll explore how these cities also improve lives through citizen engagement and inclusive digital platforms. If you're inspired by a greener, smarter world, hit like, share your thoughts in the comments, and subscribe to stay ahead of the future of urban innovation. Visual. A city at sunset, powered by solar and wind, glowing with clean energy and possibilities. Green spaces and urban forests improve air quality and reduce the heat island effect. Visual. Lush tree-lined streets, rooftop gardens, and families enjoying urban parks. Transition to aerial views of dense green canopies across city blocks. In the concrete jungles of today, nature is making a comeback. Smart cities understand that green spaces and urban forests are essential infrastructure, improving air quality, enhancing well-being, and fighting back against rising urban temperatures. Section 1. The urban heat island problem. Cities filled with buildings and asphalt absorb and trap heat, creating the urban heat island effect, where temperatures can be 5 to 7 degrees Celsius higher than surrounding rural areas. This leads to increased energy consumption for cooling, higher health risks, especially for vulnerable groups, poor air quality, and uncomfortable living conditions. But there's a natural solution: trees and green spaces. Section 2. Benefits of urban forests. Urban forests and green corridors shade streets and buildings, naturally cooling the air, absorb CO and release fresh oxygen, trap pollutants and dust, purify the environment, create natural wind corridors that improve airflow. They act as the lungs of the city, and their benefits grow with every tree planted. Section 3. Smart integration of green spaces. Smart cities plan greenery with precision, using data and sensors to identify heat hotspots and prioritize tree planting, monitor soil health and irrigation needs using IoT devices. Design multi-use green zones, parks that also serve as rainwater catchments or biodiversity reserves. These green zones are placed strategically near transit hubs, schools, and business districts, making them accessible to all. Section 4. Community and climate resilience. Green spaces aren't just about the environment. They build stronger, more connected communities by providing areas for recreation, relaxation, and social interaction, safe, walkable spaces that encourage physical activity, buffers against extreme weather and flooding, They also raise property values, reduce healthcare costs, and boost mental health for urban residents. Green infrastructure is not optional, it's essential. Urban forests and parks are powerful, natural allies in the fight for cleaner air, cooler streets, and healthier cities. In the next chapter on Civil Engineering Edge, we'll explore how smart cities use citizen feedback and digital platforms to create more inclusive, people-centric development. If you care about greener cities and a better future, don't forget to like, subscribe, and leave a comment. Let's build a smarter, more sustainable world together. Visual. A peaceful aerial view of a tree-filled cityscape merging seamlessly with technology and human life. Smart water management systems optimize water usage and prevent waste. Visual. Flowing water through smart pipelines, animated dashboards showing water levels, and satellite views of water-efficient cities. Water is the lifeblood of every city. But as populations rise and climates change, managing this precious resource becomes a challenge. Smart cities are stepping up with smart water management systems that track, optimize, and conserve water like never before. Section 1. The water crisis in urban areas. Urban areas often face overconsumption, leaks and infrastructure failures, water contamination, and growing stress on supply systems. Traditional approaches are reactive, but smart systems are proactive. They predict, detect, and correct issues in real time, preventing waste and ensuring safe delivery. Section 2. How smart water systems work. Smart water systems rely on IoT sensors placed throughout the water network, real-time monitoring dashboards that track flow, pressure, and quality, predictive analytics that flag leaks or unusual consumption, automated valves and controls that adjust distribution as needed. These tools ensure water goes where it's needed when it's needed without waste. Section 3. Efficiency at every level. Smart cities apply this tech across the board. Smart meters in homes that show real-time usage and detect leaks. Gray water recycling systems in buildings to reuse sink or shower water. Storm water harvesting integrated into urban design. Drought management tools that help cities plan and serve ahead of time. Every element works in sync to cut waste and protect supply. Section 4. Environmental and economic impact. The benefits are huge. Reduced water loss by up to 30%. Lower maintenance costs, safer, cleaner water for residents, and a reduced environmental footprint. Smart water systems also support resilience during climate stress, ensuring cities stay hydrated even in dry times. In a smart city, even something as fundamental as water becomes part of a high-tech, sustainable vision. By optimizing water usage, cities not only protect resources, but also build trust, health, and resilience for all. In the next part of Civil Engineering Edge, we'll explore how smart waste management is transforming urban hygiene and sustainability. Like, share, and subscribe to stay informed on how our cities are becoming smarter one system at a time. Visual. Drops of water ripple across a digital city blueprint, blending technology and nature into one sustainable flow. The future of urban living. Visual. A futuristic skyline glowing at dusk, smart mobility pods moving smoothly, children playing in green parks, and people walking in clean, walkable neighborhoods. Everything we've seen: smart mobility, green infrastructure, digital innovation, and sustainable design is building toward a single goal: reshaping what it means to live in a city. Welcome to the future of urban living. Section 1. A human-centered smart city. The smart city of the future isn't just about advanced technology. It's about people. Imagine a city that's walkable and accessible to all ages and abilities. Digitally connected but deeply rooted in community. Safe, inclusive, and designed for well-being over congestion. Here, innovation serves quality of life, empowering citizens to live better, not just faster. Section 2, living smarter, not harder. From your morning commute to your home's energy use, every aspect of life is optimized through real-time data, personalized by AI, enhanced by green planning and responsive services. Public services become more efficient, daily routines become simpler, and the urban environment becomes an extension of your comfort and creativity. Section 3, inclusive, resilient, and sustainable. Smart urban living ensures that no one is left behind. These cities aim for social equity through affordable housing and access to tech, climate resilience with sustainable infrastructure, community voice, where planning is driven by public participation. Smart doesn't mean cold or mechanical. It means adaptive, sustainable, and human-focused. Section 4, the path ahead. The journey to a smart city is ongoing, and it's built with every step we take in civil engineering, architecture, governance, and innovation. As challenges grow, so do the opportunities. With collaboration, vision, and smart infrastructure, we're not just creating cities, we're shaping a future worth living in. This is more than planning. It's transformation. It's the rise of a new way to live, move, and thrive. Thank you for joining us on this journey through the cities of tomorrow. If you believe in this smarter, greener, and more connected future, make sure to like this video, share your thoughts in the comments. Subscribe to Civil Engineering Edge for more inspiring content at the intersection of engineering and innovation. Visual, a peaceful nighttime view of a smart city alive with soft lights, green rooftops, and smooth traffic, all powered by intelligent systems. Logo, Civil Engineering Edge. Smart cities offer improved quality of life with enhanced public services and citizen engagement. Visual, smiling residents using public touchscreens, mobile apps for city services, and digital town halls. Kids playing in safe parks, elderly using automated crosswalk assistance. Smart infrastructure isn't just about sensors, AI, or automation. At its heart, it's about people and how we can use innovation to create cities where everyone can live better, safer, and more meaningfully. Section 1. Seamless public services. Smart cities make everyday life smoother through responsive and reliable public services. Imagine buses and trains that run on time based on real-time demand. Waste collection scheduled only when bins are full. Street lights that brighten as pedestrians approach. Healthcare alerts and telemedicine services built into daily systems. These aren't distant dreams, they're already being implemented in pioneering cities around the world. Section 2. Citizen-centric technology. In a smart city, citizens aren't just users, they're contributors. Mobile apps allow residents to report issues like potholes or outages in real time. Participate in community planning with digital town halls. Track local government actions and spending. Access digital records, permits, and utility bills with ease. Technology becomes the bridge between people and policy, making governance more transparent, efficient, and accountable. Section 3. Inclusive, engaged communities. But perhaps the greatest success of a smart city is engagement. Smart urban planning creates spaces for dialogue and co-creation, encourages youth participation through digital education platforms, ensures elderly and disabled-friendly access to transport and infrastructure, builds diverse, thriving neighborhoods through inclusive design. When citizens feel heard, connected, and empowered, the city becomes more than a place, it becomes a shared experience. The future of transportation and urban planning isn't just about how we build, it's about who we build for. And in smart cities, the answer is clear: everyone. At Civil Engineering Edge, we believe the next generation of cities will not only be intelligent, but truly livable. Like, share, and subscribe if you're inspired by the possibility of smarter, fairer, and more connected urban living. Let us know in the comments, what feature would you love to see in your city of the future? Visual, A city illuminated not just by lights, but by people interacting, laughing, commuting, and connecting, powered by smart systems and human spirit. Logo: Civil Engineering Edge. Data-driven decision-making fosters efficient resource allocation and public safety. Visual: a busy urban area with data points flowing over city maps, police cars with digital surveillance systems, and city officials reviewing data on large screens in a control room. In a smart city, data isn't just information, it's the key to making better decisions, faster. From resource management to public safety, data-driven decision-making is transforming how we govern and optimize urban environments. Section 1. The power of data in urban management. Data is collected at every level of a smart city, from traffic flow and energy consumption to weather patterns and social behavior. This data is analyzed in real time, processed through advanced algorithms, transformed into actionable insights for urban planning. With a constant stream of data, city officials can make decisions that are more precise, timely, and effective than ever before. Section 2. Optimizing resources and services. With smart technologies and data analytics, cities can optimize resources in ways that were impossible before. Energy grids can be adjusted based on real-time demand to reduce waste. Water usage can be monitored and corrected instantly to avoid shortages. Public transportation schedules adapt to crowd density, reducing congestion and wait times. This leads to efficient resource allocation, ensuring that every dollar is spent where it's most needed and every service is delivered on time. Section 3. Enhancing public safety with data. Public safety is one of the most critical concerns for any city. In smart cities, data and analytics are playing a vital role in making neighborhoods safer. Predictive policing uses data to identify crime hotspots and deploy officers where they're needed most. Smart surveillance systems track public spaces for potential threats, sending real-time alerts to authorities. Emergency response is improved through data analytics that prioritize incidents based on urgency, reducing response times. The result: safer streets and quicker responses to emergencies, backed by powerful data-driven tools. Section 4. Predictive maintenance and incident management. Data also helps cities prevent problems before they happen through predictive maintenance and incident management. Sensors monitor infrastructure like roads, bridges, and pipes for signs of wear and tear. AI algorithms predict when equipment might fail, triggering maintenance before a breakdown occurs. Dynamic routing for emergency vehicles and first responders based on real-time data from traffic and road conditions. This predictive approach ensures that resources are used proactively, saving time, money, and lives. Closing out row and CTA. By turning data into action, smart cities not only run more efficiently, they become safer, more sustainable, and more responsive to the needs of their residents. Data-driven decision-making is the foundation upon which we build the cities of tomorrow, ensuring that every resource is used effectively and every citizen can thrive in a secure environment. If you're excited about the potential of data-driven urban planning, like, share, and subscribe to Civil Engineering Edge for more insights into the smart cities revolution. Drop your thoughts and questions in the comments. What aspect of data in cities would you like to explore more? And stay tuned for our next video, where we dive deeper into the role of digital twins in urban planning. Visual: a bustling city with data flowing through streets, buildings, and transportation systems, gradually transitioning into a digital city blueprint, showing interconnected systems optimizing resources. Logo: Civil Engineering Edge. The integration of smart technologies creates a more equitable and inclusive urban environment. Visual: diverse groups of people walking in well-planned urban spaces, using smartphones to navigate, enjoy clean public spaces, and access digital services. As cities evolve through innovation, one of the most exciting possibilities is the potential for equitable urban environments. Smart technologies are not just transforming infrastructure, they're leveling the playing field, ensuring that everyone, regardless of income, age, or ability, has access to the opportunities of the modern city. Section 1. Access to services for all. In a smart city, equity is at the core of every design and decision. Affordable housing is integrated into the urban fabric with access to sustainable resources and modern amenities. Digital access to public services, whether it's healthcare, education, or government services, is available to everyone. Mobility options like autonomous shuttles or bike-sharing programs serve people of all socioeconomic backgrounds, ensuring equal access to transportation. Smart cities use technology to bridge gaps, making life easier for all residents, especially those who were traditionally left behind in urban planning. Section 2. Inclusivity in urban planning. Inclusivity is more than just access, it's about empowerment. Smart cities encourage community participation through digital platforms where citizens can voice concerns, suggest improvements, and shape decisions. Adaptive public spaces designed for diverse needs, from playgrounds to community centers. Data-driven policies that address inequalities, like optimizing resource distribution in underserved neighborhoods. Through active engagement and targeted innovation, smart technologies make urban spaces truly inclusive, ensuring that everyone feels they belong. Section 3. Empowering marginalized communities. Smart cities also focus on empowering historically marginalized communities. Real-time data is used to identify and address issues like air pollution, traffic congestion, and access to green spaces in disadvantaged neighborhoods. Public services such as emergency alerts, healthcare resources, and educational tools are made more accessible through technology. Economic opportunities are created by providing skills training and digital literacy programs, helping individuals from all backgrounds thrive in a tech-driven economy. The integration of these technologies ensures that no one is left behind and that the benefits of innovation are felt by everyone. Section 4. The future of equitable cities. The future of urban living is not just about building smart cities, it's about creating cities that care. Cities that value diversity, foster inclusion, and offer equal opportunities for everyone to thrive. Smart infrastructure enhances social equity by ensuring that resources are allocated fairly. Technology empowers residents to participate in decision-making, making them active contributors to the future of their communities. With data and innovation working hand in hand, smart cities can tackle the root causes of inequality, leveling the playing field for all. Conclusion: from smart mobility to sustainable energy, from digital services to inclusive public spaces, the integration of smart technologies is shaping cities that are more efficient, sustainable, and equitable. This vision for the future isn't just an idea, it's becoming a reality, driven by innovation and powered by people. Smart cities are transforming the way we live, work, and interact, making urban environments more connected, resilient, and inclusive than ever before. But we are only at the beginning. As technology continues to advance, the possibilities for smart cities are limitless. The future of urban living will be defined not just by what we build, but by who we build it for. So, whether it's through data-driven decision-making, innovative transportation, or creating equitable spaces for all, we're building cities that truly reflect the needs and aspirations of everyone. Thank you for watching this journey into the future of smart cities. If you're inspired by the potential of these innovations, make sure to like, comment, and subscribe to Civil Engineering Edge for more insights into the transformative power of smart city infrastructure. What excites you most about the smart cities of tomorrow? Let us know in the comments below. And stay tuned for more groundbreaking content. Visual: a vibrant, fully integrated smart city with diverse groups of people smiling, interacting with technology, and enjoying a connected, sustainable environment. Logo: Civil Engineering Edge.